Yeah, hi guys. Like you guys remember, I had told you at the end of the video earlier that we are going to begin with a chapter 6. So here it is. We are just starting a chapter 6 now. See, the thing is, we are not picking up Euclid geometry for now because that is a theoretical portion. Majority of those things you guys already remember. So it is just exams and postulates. So once we have finished up our chapters which are more interesting, I will be having that chapter to discuss with you. I found this chapter to be quite interesting, so I chose it to be the chapter that we should focus on right now. Because while you are on your chapter 6, 7, and 8, followed by your 9, so these four chapters constitute major of your portion of your exam, and they have a lot of actually, they just constitute a lot of marks for your exam, and you have many sums based on these concepts can be asked in your exams. So roughly an examiner, if he or she wants to put up a paper or set a paper for you guys, he or she will be adding at least 3 to 4 sums based on these 4 chapters. So whatever you learn in this chapter, that will be taken and focused on your chapter 7, and whatever you have learned there followed with chapter 8, then you will be following up with chapter 9. So remember, all these 4 chapters are quite important. You cannot skip any of those. You have to just remember that you have to keep the grab of each and every concept that I'm going to tell you. Majority of these concepts you guys already remember from your earlier classes, like your lines and angles, types of lines for that matter, line segment, ray, everything, finding out angles in the case of parallel lines, intersecting lines. So each and everything is already known to you. You guys must be remembering those. But there will be some new concepts while you're moving towards the end of this chapter. There will be some theorems in exams also that will be governing some concepts that you guys already know, that on a straight line, if you have a ray which is intersecting, it is falling on the straight line, then the sum of the angles formed there will be 180, and like those, you guys will be remembering the case of parallel lines, alternate interior angles are equal, why they are equal, actually why they are equal, we will be understanding them now. I will be proving each and every concept, but that will be on a steady pace. I will not be covering up this entire chapter in one sitting because that is not just possible to cover this entire chapter. I will be having 3 sessions. I am thinking of having 3 sessions, but that depends upon the situation and the length of the sessions and the length of the chapter. So if I keep on with a steady pace, I might be able to finish up with the theoretical portion till your Friday, and on Monday most probably we will be having our doubt sessions. So I hope you guys will be joining me for that. So without wasting your any more time, just take out your pens and notebooks and let's just start with the chapter. So let's study with a brief introduction. So you guys see introduction, you guys already remember this chapter is the part of the concept which is geometry. So geometry is that branch of mathematics that deals with measurement, size, positions, basically the physical appearance of anything. If you're talking about that, you guys remember your coordinate geometry also. Here you there you studied the distance or that position of that object with respect to any other object, right? So you guys remember we had understood sizes and shapes there as well. We had squares there, we had rectangles there, we had various shapes also. You guys remember we had find out the coordinates of remaining points. So all of these things are the part of geometry. While you're talking about coordinate geometry, that deals with the position of an object. But if we're generally talking about a geometry, that is what? That is the shape, size, measurement, position, anything that is related to the physical appearance of that object, that becomes the part of geometry. So in this chapter, we are going to focus on our lines and angles. Then we will shift towards our triangles. Then we will focus on our quadrilaters in our chapter 8, followed by the area of parallelogram and triangles. So these are the concepts which we will be studying in our class 9 related to geometry. Then we will be moving toward our mensuration. We will be having circle portion also. Chapter 10 will be there as well, that is circle. So after chapter 10, we will be focusing on our various other chapters that will be the part of your mensuration and followed by some data interpretation. So this is the thing that we have to understand and we have to remember. So remember, geometry is what? This is geo and metron, where geo means earth, or you can say any physical object, and metron means measurement. It is the Greek word. So what do we have in this chapter? So let's just get around the basic terms and some definitions. So you guys see our first basic term is what? It is line, but actually you guys should be remembering what is point. The point is what? Point is a dimensionless position of any given coordinate. It is what? It is the vertical and horizontal distances from your x's, right? If it is a two-dimensional plane, then you will be having coordinates like this, x comma y. So this position will be having some coordinates, and this will be what? This will be a point, right? The point is any dot, you can say it is any dot in any plane. It does not have any dimension. We cannot call it whether it is a two-dimensional thing or it is a three-dimensional thing or whatever that is. Although it can lie in various dimensions, but point itself does not have any dimension. So it is dimensionless situation. Now, what do we have now? What is line? So you guys remember, while we were dealing with many points, you guys knew if we had two or more points, and if they were lying on the same line, then you guys see we had called them collinear points, right? So collinear points were what? They were those points which were lying in a straight path. So a line is what? Line is a connection of infinite points in a straight path. So that is what? That is a line. So you guys remember we had this kind of thing, right? We had plotted some points which were having coordinates like this: 1, 2, 1, 3, 1, 4, 1, 5. So you guys remember in this case we had the x coordinate same, but y was varying. So our line was like this, parallel to y axis. Do you guys remember that? Yeah, that was what? That was the line which was parallel to y axis, and it was straight. So guys see, we could have as many points as we wanted on that line. So when you combine all those points and they are falling on the straight path, then the join, the conjuncture of those points will be what? That will be your line. Now we have another things related to that. So let me just direct you here. You guys see we have a line right here, right? So I'm going to do what? I'm going to mark 2 points right here. Let's say this is point A and that is point B. Okay. Now from these, I will be explaining the remaining 2 terms. So firstly, I do what? I just pick out this A and move towards B. It looks like this. Here is A and here is B. Now you guys get an idea. Array is what? Array is a part of line which has one point which should be the end point, and on the other side the line will be extending. And from here I will be telling you this also. I think I've skipped that. A line never ends at any point. A line does not have any end point. It is extending on both directions. So you guys see, if I had drawn that one, that case where we had those points, so you guys see there were infinite points, right? So when you combine infinite points on either of the sides, you will be getting a line, and line will not be having any end point. Although ray will be having one end point, but it will be continuing on the other side. Now you guys see, if you wanted to name a line, how will you be naming it? You will be naming it by just having any of the 2 points on it. Let's say I had these A and B points, right? So I will be doing what? I will be writing AB, then I will be marking 2 arrows followed by a line over them. So this represents that I have a line which is AB and it is extending on both sides. Now for the case of ray, you guys have got this already. So ray is what? Ray is the portion of line which is ending on the one side but extending on the other. So if you want to name this one, so you guys see I had this A and that one B. So it will be what? It will be like this, names of the points falling on it. Wherever the line is extending, I will be marking on arrow on that side. So you guys see, I knew the ray was extending past B, so I will be putting an arrow pointing towards B. If the ray had been extending over A, it had been like this, B and this one A. So it should have been like this, AB, arrow pointing towards A. So that is what? That is the name for the ray. Now for the case of line segment. The line segment is what? Line segment is that part of the line which cannot be extended on either side. It is of limited length. It has 2 endpoints on either side. So you guys see I have this way a line segment here. Let's say this is A and this is B. Or if I take this example AB, if I just mark out only this distance. Now you guys see I'm just focusing on the distance which is falling between A and B. So the part of line which has 2 endpoints, that will be what? That will become your line segment, and we are going to name it like this: AB followed by just a line over it, or you can say a bar over it, or you can call that a vernacular, but that will be totally different because that will be the portion of your V board mass or your simplifications. So just call it a line. So AB, a line over them, and there will not be any arrow since the line is not extending on either side. So I hope you guys can recall each and every of these 3 terms. So let's move forward and see what do we have next. So parallel lines, you guys remember, if we were dealing with 2 or more than 2 lines, you guys remember there were 3 situations. Either the lines will be parallel, either the lines will be perpendicular, or they will be intersecting or transversal lines. Just a difference between your transversal and intersecting, I will be explaining it in a bit. Firstly, parallel lines. So what are parallel lines? Parallel word is, you guys should be using this word quite often from your earlier classes also. You guys always write it like this: AB is parallel to CD, and there is the case of parallelogram. So what actually is a pair of parallel lines? The parallel lines are what? These are those lines which do not share any common point. I will be referring to angles, and you will be understanding on the basis of angles later on. I will be defining parallel lines with multiple definitions, but first of all, the most common definition is this: a pair of line which do not meet at any point. That means they do not share any common point. So you guys see this, I have a pair of parallel lines right here. AB is a line, CD is a line. So you guys see AB and CD, and here I want to reduce something also. So you guys see I have this AB and CD. I have told you that AB, that means a line, is never ending. It can be extended on either side. So if I do what? If I just mark 2 points over here, let's say if I mark this C and D, sorry, C is already there. Let's mark E and F. Okay. So what happens here is, I know AB will be parallel to CD as long as they do not share any common point, they do not converge at any common point, they do not diverge from any common point. So that means the distance between them at any given point, if that distance is same, then I can say lines are parallel. So common example of those will be what? Your railway tracks. You guys see railway tracks are parallel to each other, they never meet. Even the distance between the tracks is same at any given point. So that will be what? That will be an example of parallel lines. Now you can take an example of roads also. So if you have just a road, you guys see it is what? Roads actually are what? If I just point out two objects right here, considering the distance is same, they will be also parallel. You guys see the dividers between the roads, they are mostly of equal lengths. If we are moving on the highway, they are of equal lengths, right? So that will be the case. The medians inside the roads, those are what? Those are also parallel. So there are various things that can be deduced as parallel. So if I do what? If I just draw a figure right here, let's say if I have a square ABCD. So you guys see this distance, see whatever the distance is here, that is same as here. So I can deduce that this line will be parallel, this line segment will be parallel to that. So that is a total different scenario while we are dealing with quadrilaters. So I will be explaining these concepts here. Although if you guys remember from your class 8, you had the concept of quadrilaters, right? So you guys remember that from there also. So what I was telling you guys, I used 2 points right here, E and F, and I had told you that AB will be parallel to CD provided the distance between AB and CD is fixed and it is not changing. That means neither it is increasing nor it is decreasing. So those points, those pair of lines will be what? They will be a parallel lines, right? Now if AB is parallel to CD, then remember this, part of AB will be parallel to part of CD also, or part of AB will be parallel to CD also. See, if I have this EF, EF is part of AB, right? This whole AB is parallel to CD, then EF will also be parallel to CD. These are some axioms and theorems. We will be proving them later on. So I just want to tell you these things can happen also. Now next point is our perpendicular lines. So these are the word perpendicular. You guys always use this one while you're talking about an angle of 90 degrees, right? If you're talking about a right angle triangle, if you want to construct a right angle triangle, you do what? You just take a base and construct a 90-degree angle, or you can do what? You can take a line which is perpendicular to your base. So perpendicular means those pair of lines which are intersecting. Now word intersecting means when two lines cut each other at a distinct point. So you guys see, if I just look at this picture, firstly, this hasn't been disclosed that these lines are perpendicular. The first thing I can deduce from this picture is that these are what? These are my intersecting lines. Okay, so these are intersecting. Then if we are given that the lines while intersecting each other, they are making an angle of 90 degree. Now guys, remember this symbol is what? The symbol is of 90 degree. So guys see, if it has been given to you that while the lines are perpendicular, they are intersecting each other and they are making an angle of 90 degree with each other, then those lines will be what? Those lines will be perpendicular lines. So in this case, if I have a line A and if I have a line B, both of them are perpendicular. So symbol that I use for perpendicular is what? It is this one, an inverted T. So you guys should be remembering this, right? So perpendicular lines are those lines which intersect each other and make an angle of 90 degree. Now we are moving towards our transversal lines. So what are transversal lines? See, transversal line or lines are generally more than two lines. If I just tell you like this, see, let's say if I have two lines right here And if I have a third line which is intersecting these two lines at two distinct points, let's say this is the point 1 and this is the point 2. So you guys see that line is intersecting the other two lines at two distinct points. So that will not be an intersecting line. That will be what? That will be a transversal. So remember, transversal intersects more than one line at two distinct points. Two or more than two distinct points. So that depends upon the number of lines that we are taken. So the line which passes through two or more than two lines and has two or more than two distinct points, that line will be a transversal, and group of those lines will be what? Those will be transversal lines. But if I talk about only this, if I have A and if I have this T, so this is what? This is an intersecting line, not a transversal. Remember this is not a transversal. Although if I have a line B and if I'm talking about this T, now this T is what? This T is a transversal line. It is not generally an intersecting. But if you're talking about these two, they will be intersecting. If I'm talking about all these three, they will be what? They will be are transversal lines. So I hope you guys remember this and you don't have any doubt in this. Now let's move forward and see. So the basic difference between these intersecting and non-intersecting lines. So two or more lines, here one common point, that will be intersecting lines, right? If there are distinct points, that will be transversal. Now here I want to tell you something. So if I have just one point, how many lines can you think can pass from this? This question is already repeated in our chapter 3, I guess. We had repeated this question in a chapter 3, I guess. So if I have just one point, how many lines can you think pass from this? So you can see this is just a one point. You can pass as many lines as you want. Now you guys see, if multiple lines are passing through one common point, those lines are what? They are concurrent lines. Let me just write it here. If multiple lines pass through one point, those are concurrent lines. Remember this. If multiple lines are passing through just one point, those lines will be concurrent line. Another name can be intersecting lines. Now here I want to ask you one more thing and then tell you how many lines can you think pass from these 2 points? How many lines can pass from these 2 points? And that has to be a line, not a curve. So you guys see, I can only have one line that can pass through these 2 points. So if you have more than one point, there can be one line that can pass through all those points. There can be only one line. If there is one more line, then remember that cannot be a line, that will be a curve, because there is no other line that will be passing through to those points, and that will be a distinct line. See, I can have as many lines as I want that should be passing on from these 2 points, but those lines will be what? They will be falling on one another. They will be falling on one another. So in short, there will be just one line. You can just mark out as many lines as you want on that, but that will be counted as just one line because there is only one line at a given time that can pass through it. Let's just come back to our topic right here. So intersecting lines, 2 or more lines which shares one common point, intersecting lines, or you can say concurrent lines. Intersecting lines meet at only one point, no matter at what angle they meet. There is no condition regarding an angle. They can have any angle that they can form, but there will be just one common point. Now no two straight lines can meet more than one point. Now you guys see, this is already discussed with you. The lines that meet at more than one point are not straight. One of them has to be curved. So I've already explained this one. So these are the quick differences, or you can say quick conditions, to check whether the given pair of lines are intersecting or not. Now for the case of non-intersecting lines, these will be what? These will be a parallel lines. Their distance is always same. They never meet at any point. Their distance remains the same. So these are the 4 points that distinguish your lines. I hope you guys understand this and you don't have any doubt in this. Now let's see, what do we have next? Pardon for the ringtone. I think my phone was ringing. Sorry, I forgot to silent it. Now let's just move forward and see what do we have. So we have this one. We have the types of angles with us. So you guys already remember what is the actual definition of angles. You can just quickly tell me in the chat also. So you guys see, an angle is what? If you have two rays, let's say I have two rays, or let's say if I have two lines. Okay, let's say this is a line P and this is a line Q. Remember, if you want to label the lines, then you have to put arrows on the either side. Now you guys see, if I just consider this point, I have these intersecting lines with me. So if I just name this point, this is the point where both of the lines are intersecting. Let's call this O. So if I just focus on this figure right here, so I have something like this, P, Q, and this one is O. Like, now you guys see, if I look at these two arms, I can see these are rays. So what I want to tell you is, if two or more rays share one common vertex. Now in this scenario, let's just consider if two rays meet each other at one common vertex, or I can say if two rays emerge from one common vertex, then the distance between both of those two rays, this distance right here, this will be what? This arc will be what? It will be an angle. So this is an angle. I hope you guys understand this and you guys can remember from your earlier classes also. So angle is what? Angle is generally the distance between two adjacent arms. That is the point I want to discuss with you. So this is the thing. Now we have types of angles with us. These are quite easy. I will be just elaborating them. Acute angle, obtuse angle, right angle, reflex angle, and straight angle. Acute, you guys see, if I just draw a perfect 90-degree angle, it should be looking like this. Now guys see, this is less than 90. So obviously acute angles are always less than 90. So any angle x can be acute if it is less than 90. Now guys see, if I just draw a right angle right here quickly, so you guys see this is more than 90. So any angle x will be an obtuse angle if it is greater than 90 degrees, but it has to be what? So if I just write it neatly here, let me just write it fully. So an obtuse angle will be that angle x which is greater than 90 degrees, but it has to be less than 180 degrees. So this is the condition right here. Now for the case of right angle, it is exactly an angle x will be right angle if it is 90 degrees. Now reflex, a reflex angle will be that angle, an angle x will be reflex if it is more than 180 degrees, but it is less than 360. That is the limit for a reflex angle. Now for the case of straight angle, you guys see on a straight line, the maximum angle that you can get, you can say this is what? This is an angle of 180 degrees. So a straight angle, any angle x will be called a straight angle if it is of 180 degrees measurement. So I hope you guys can recall each and every of these angles. So let's move forward and see what do we have now. So basic terms, now you can just get this one. Less than 90 will be acute. More than 90, less than 180, obtuse, already explained. Right angle, exactly 90. Straight angle, exactly 180 degrees. Then reflex, which is greater than 180 but less than 360, already explained. Complete angle. Now you guys see, if you take a complete circular round of any point, you guys see, if I just draw it right here, you guys see, if I just look upwards, this is the maximum angle that I can get. This is 180 degrees. If I look downwards, I will be having 180 more. So if I start from here and move all the way back, so 180 plus 180, that will be what? That will be 360. So a complete angle is what? A complete angle is the total rotation. So it will be what? It will be 360. While you're moving in your class 11, you guys will be having this term also, your term pi by 2. It is actually 22 by 7, but its value is 90 degrees in the terms of radine, not degrees, radine. Then you will be having 180 that will be represented as pi, and likewise. So remember, pi can also be denoted for these angles. So don't get confused if somehow you get these in your paper, which is highly unlikely that an examiner will be asking you this one. But just know this if they have asked you. So remember, pi means 180, pi by 2 means half of that, and you can get the idea. If you are talking about 270, you have 3 pi by 2, that means 390 angles, and for about 360 you will be having what? A 2 pi, twice of this, or you can say 4 right angles. So these are some basic terms that you should remember, but you don't have to, you should. Now let's move forward and see complementary angles. Now here we are starting a pair of angles. So pair of angles, how can we get a pair of angles? Now this can happen if we have what? If there were 3 rays, let's say if I call 3 rays, and they all were sharing the same common point. Let's say something like this. Let's say this is a ray B, C, D, and let's say the common vertex is A. So you guys see, now we have 3 rays, all of them are sharing the same common vertex A. So the distance between these two will be one angle, distance between these two will be another angle. And now here we are talking about 2 angles. So remember, these are the 2 angles. Now angles can be formed on any side. Now these can be like this also. If I erase this, now we can have something like this also. See, the figure can be rotated, it can be even like this. let's say this is ray, this is ray. Although this will be a line if this angle is 180. If it is not 180, then I will be calling them rays, although this can be line also. So let's just focus on a pair of angles. So now we are talking about complementary angles. So what are complementary angles? So complementary angles are those angles which add up to a 90 degrees. That means two angles whose sum adds up to 90 degrees, those angles will be complementary angles. Don't get confused here. Complementary, actually you guys will be thinking that it is sounding somewhat like a complete angle. So it has to be what? It has to be 180. Sorry, it has to be 360. Not that, because you guys see complementary means 90 and supplementary means 180. So if you have a pair of angles whose sum is 90, then you guys see that will be what? That will be a pair of complementary angles. If you have a pair of angles whose sum is 180, then you can say those are your supplementary angles. So how can you achieve an angle, a pair of angles which amount to 90 degrees? So it can happen like this. Let's say if you have a 90-degree angle and there is, let's say, a line segment sharing the same common point, or there is another way. So you guys see there will be two angles, both of them will be amounting to the same 90-degree angle. This will be discussed in our Euclid geometry, which is not quite necessary here. You guys should be remembering this. If I add 1 and 2, I will be getting a 3. So I can write 3 like this, 2 plus 1 also. So it does not matter, I can part this one, but our whole will be same. So if our whole is 90, so I can write 90 with various ways. I can write it like this, 45 plus 45. I can write it like this also, 30 plus 60. I can write it like this also, 15 plus 65. So I can write with, it should be 75. So I can write with any way. I can expand them and write them in any way. So you can write it any way that you want, but you should be having pairs of angles. Remember, you cannot have 3 angles and you add up to get 90. Those angles will not be called a complementary angles, because complementary angles are exactly 2 angles. There you will have to use something else, or you have to do what? If you are having more than 2 angles there, so just add any 2 together, then consider some of those 2 as one and the remaining one as another. So add them, and if you get 90, then you can use the complementary angle theorem, but complementary angle case, but don't assume them like this. So I hope you guys understand your complementaries and supplementaries. So let's move forward and see adjacent angles. So what are adjacent angles? Adjacent angles are those angles which have a common side and a common vertex. If I look at this figure, if I just tell you, if two angles are separated by one transversal or one common vertex, then those angles will be what? Those angles will be your adjacent angles. We are going to deal with adjacent angles later on while we are having our parallel lines. So for now, just remember this: two angles will be called adjacent angles if they have one common vertex and they have one common side. That will be the pair of adjacent angles. Now vertically opposite angles, those angles or those pairs of angles will be called your vertically opposite angles if they are not adjacent, if they are directly opposite to one another. See, the trick I here want you guys to understand, and the trick that I use to just check vertically opposite angles, if you are dealing with two lines, like in this case you have an AB and a CD. So you guys see, whenever you get a situation where the lines are making an X, then remember, if you have the common vertex, then the angles which are opening their faces, or you can say their mouths, on the other side opposite to one another, those angles will be equal. So you guys see, this angle is towards the right side, and you can say this is towards the left hand side, or you can just call this upward and downward, whatever you want to call it. But the thing is, these two angles are directly opposite to each other, so they will be what? They will be exactly your vertically opposite angles, right? And remaining like this also, if you have an angle which is facing upwards and another angle which is facing downwards, so these two angles will be equal. Now you can look here. If I just name the angles, you guys remember the namings of angles also, right? So any of the two vertices should be written apart. Like in this case, the distance vertices are A and C. So let's write them like this: A and C, and the vertex, the common vertex of those arcs, which is O. So angle will be what? Angle AOC, right? Similarly, you can call this one like this also, angle COA. It does not matter which distant vertex, vertex is written first. You can write either of those, but the point of the common vertex should be in the middle. So this is how you're going to name them. Now you can look here, this angle right here, angle AOC, it is 35, angle DOB, it is also 35, and angle AOD, it is 145, and angle COB, it is also 140. So guys, see, these will be what? These will be your vertically opposite angles. I hope you guys understand them, right? Now, corresponding angles. So corresponding angles are those angles while we are dealing with the parallel lines. Let's say this is the scenario right here. Now here we are going to focus on our parallel lines. So if you have a set of parallel lines or a pair of parallel lines, and if you have a transversal, then remember the situation can arise here, and you will be having a pair of angles which will be called corresponding. If both of the angles are on the same side of transversal, the first condition is that they have to be on the same side. So you guys see, I can see these two angles, they are on the same side of the transversal on the left hand side, right? Then there will be one more condition, that one angle will be on the outside of the parallel lines and another one will be on the inside. Now you can look here, our first angle, which is this 70, it is outside of these two parallel lines, right? It is on the outside, and this one is on the inside. Now you guys see, if they are lying on the same side and one is outside and one is inside, then these two angles will be what? They will be equal. That is from an exam. I will be explaining them later on while we are having conditions there. So remember, these are kind of your corresponding angles. Similarly, you can have these angles also. This angle right here will be same as this one. Similarly, this angle right here will be same as this one. Similarly, that angle right here will be same as that one. So you guys see, these things can happen. Now we are focusing on our alternate interior angles. So alternate means opposite, interior means inside, and angles are already your angles. So if you are dealing with those angles which are on the opposite sides of transversal, but they are lying on the inside of parallel lines, the condition is the alternate interior angles are formed when a transversal passes through two lines. The angles are formed on the opposite side of transversal, remember, and inside of the two alternate interior angles. So you guys see what I'm trying to tell you. If I look at this figure, I will be having what? There will be a transversal, which is this one, and the pair of angles which are on the opposite side of transversal. You guys see this angle, let's call this one X, and let's call this one Y, and let's say this is Z, and let's say this is W. Okay. So now those angles which are on the either side of transversal and they are in the opposite direction, or if I just tell you quickly or just in short, remember those angles which are on the either side of transversal but their faces or mouths are opening on the opposite side. So if I just focus on this one, let me just erase this. So you guys see, this angle is pointing towards up and this is pointing downwards. So you guys see, they are opening their mouths or faces on the others on the opposite sides, and they are separated by the transversal. So both of these two angles will be equal. They are alternate interior angles. They will be equal. I will be explaining to you how later on while we are talking about our proofs. So remember, these are your alternate interior, not necessarily these only. We will be having these two as well. So remember, corresponding angles, same side of transversal, up and down. That means outside of the parallel lines, and one should be on the inside. But the case of interior, opposite side of transversals, opening their faces or mouths on the opposite side, or you can say that pair of angles which are lying on the inside of parallel lines but are separated by a transversal. So that will be what? Those pairs will be alternate interiors, while in the earlier case, those will be our corresponding angles. So I hope I am able to clear your doubts with these, right? Now let's move forward and see what do we have now. So linear pair. Now we are moving towards some axioms and some proofs now. So remember, a linear pair is what? On a straight line, let me just conclude this one. So let's say if I have the straight line AB, what happens? Let's just not take them AB. Let's say this is CD. Okay. Let's say this is point E and that is point F. Okay. What happens here is, I have a line segment CD and there another line segment EF, such that EF is intersecting CD at point E. Now what happens here is we have two angles right here, an angle A and an angle B. So these two angles are here. So you guys see, if I did not have the straight line, let me just do it. Let me just erase this one for a second. Let's just do it like this. Yeah, here it is. So let's just get rid of this for a second. So guys see, if I did not have this line, so what happens here is that I will be having a straight line, and you guys remember the angle on a straight line is of 180 degrees, right? Now what happens is, since we had a line segment right here, so sum of these two angles itself will be what? It will also be what? It will be 180, because both of them will be amounting to the same thing. So remember, just remember this linear pair. Condition is linear pair. So in pair you have two angles. So remember, if you are adding just two angles and you are getting 180, Here you can use the property linear pair, but in other case, if you have more than two angles, then you have to add two of them, firstly two of them, then you have to add the third one. Then you will be considering again linear pair, but you can write them like this: AB plus C equals to 180. But you cannot write the property like this linear pair, because pair has two things and we are adding three, so that does not look quite accurate. So you have to do what? You have to just assume this AB to be another thing. Let's call this one D. So D plus C equals to 180. Now this can be a linear pair. I hope you guys understand this. So let's move forward and talk about our co-interior angles. So co-interior angles are those angles which are on the inside of the parallel lines and are lying on the same side. So you guys see, these will be the conditions, these two angles. Now there are some conditions regarding a co-interior lines. The condition is this: the sum of the both co-interior angles. Let's say I have two co-interior angles A and B. The sum will always be 180, and this is also a condition for parallel lines or a pair of parallel lines. If the angles, if a transversal is passing through those parallel lines such that it is forming two angles with both of the lines, and if you add both of those angles and you get 180, then you can say the line, the pair of lines, those are parallel lines. So remember, for the case of parallel lines, sum of their angles on the either side will be what? It will be 180. So this is the condition that has been written here. If two lines are parallel, then their co-interior angles will add to 180. If they are not, they will not be adding to 180, or you can say these co-interior angles will be what? It will be supplementary. They will be supplementary if the lines are parallel. So this is an important thing. You guys should remember this. So let's move forward and let's practice some questions now. So we have just our theoretical portion done. So let's just practice this quickly. So two complementary angles are in ratio 11:7. Find the angles. So you guys see, complementary angles are of 90 degrees and we are dealing with ratios. Quite easy. Let ratio equals to x, right? So first angle will be 11x, another will be 7x. Sum of those angles will be 90. In short, 18x equals to 90. So x will be what? 90 by 18. So if you solve this, you will be having what? This will be a 5. So your angles are what? A 35 and a 55, right? So your angles will be 35 degrees and 55 degrees. I hope you guys understand this, right? Now we have the next one. What is the supplementary of 20 degrees? Quite easy. You guys remember supplementary is of 180 degrees. So its supplement will be what? 180 minus 20, it will be what? 160, right? Quite easy. Now what are concurrent lines? So I've already told you, concurrent lines are those lines which share, when two or more than two lines share one common point, those lines will be your concurrent lines. Now how many lines can a line has how many endpoints? So how many endpoints does a line have? So you guys tell me. A line can have no endpoint because it is a line. We are talking about line. Line does not have any endpoint. So remember, a line will not be having any endpoint. So I hope you guys understand this and you guys are able to recall this one. But if I had asked you how many endpoints can a ray have, so tell me, how many endpoints can a ray have? Can have one endpoint, right? It is like this. And what about line segment? So it is like this. Both of them are endpoints, so it will be having at most maximum two endpoints. So it will be having exactly two. It will be having a 1, and a line will not be having any endpoint. Now, how many right angles are in a complete angle? So complete angle, it will be what? 360 divided by 90. So it should be what? 4. So you will be having 4 right angles. So I hope you guys understand this and you don't have any doubt in this. So let's move forward and start with some axioms and theorems based on lines and angles. So our first axiom states that if a ray stands on a line, if a ray or a line segment stands on a line or a line segment, then the sum of two adjacent angles formed is 180. This I've already explained it to you. So if you have this a line AB and there is a ray OP such that OP is falling on AB and it is having these two angles right here. So you guys see the maximum angle is 180 and some of these two will also be 180. So these angles are commonly termed as our linear pairs. You guys already remember this, right? So let's move forward and have this theorem. So if two lines intersect each other, then the vertically opposite angles are equal. So this is the theorem where we are going to prove that vertically opposite angles are equal. So required to prove is, you guys already know, we have to prove them that AOC, that means this angle, will be same as this BOD, then AOD, that means this angle will be same as that one. So you guys see, if I just consider this as a straight line, if CD is a line, if CD is a line, so I know, what do I know? I know this angle COA plus angle AOD, that will be what? That will be 180, exam 1. Or you can say linear pair, right? Similarly, if AB is a line, then what happens? Angle AOD plus angle BOD equals to 180. Again, linear pair. Now you guys see, if I mark this one as my first and this one as my second, so you guys see both of them are equal to 180. That means they are equal to one another. So if I just erase this, and from 1 and 2, I have what? Angle COA plus angle AOD is equal to angle AOD plus angle AOD. Now you guys see, AOD and AOD cancel out because they are the same quantities on the either side of equality. They will be cancelling out. No beta, there cannot be two. What are you telling, Monica? Infinite points 2. We are talking about this. Just write it fully so that I can answer to you. Infinite points 2. Here, if you're talking about just infinite points, then if they are falling on the straight path, they will be forming a line. But if you're talking about 2 points, there can only be just one line that can pass through those 2 points. Because practically you can think of this, if you remember from a chapter 3, let me just explain it to you real quick. If you guys remember this from a chapter 3, where we had 2 points, let's say this was a 0,6 and this was a 6,0. So there could have been just one straight line. You guys remember this? We had plotted these points, right? So the line was something like this, right? A straight line. So that was the point, right? There cannot be two lines which can pass through 2 points, but somehow I guess you're talking about infinite lines passing through a common point, so that will be a concurrent line. Yeah, a line can have infinite points. Correct. So yeah, that's right, a line can have infinite points. That is what the definition of line actually is. So if all of those points are falling on the straight path, that will be what? That will be forming a straight line, right? So let's move forward and just prove this one. So you guys see, COA and BOD, so both of them are what? Equal, right? So both of them are equal, and similarly you can prove these two also. So you can see a pair of vertically opposite angle is equal, and you can say the lines, if there are two lines which are intersecting each other, then the pair of their vertically opposite angles will be equal. So in short, we have proved this one and we can prove this one. Now it does not matter if you're writing it like the COA or AOC, it does not matter. You can write it with either way. But remember, this is only for this point. While we are on congruency, there cannot be happening something like this. We have to name them properly. So we are talking about that in chapter 7, but not now. So let's move forward and see what do we have now. So we have some examples based on that one. So we have this one. So if ratio P in figure 6.9, that is the example from your NCERT, if PQ and RS intersect each other at point O, I have two lines PQ and RS, they are intersecting at O. If angle POR, that means this one, POR, and angle ROQ, that means that one. If these two angles are in ratio 5:7, then I have to find all of these angles. So now you guys remember, when two lines intersect each other, then their vertically opposite angles are equal due to theorem 1, right? They are equal. So theorem 1, right? So that means angle POR plus angle ROQ, sorry, not that one, actually I'm just moving one step further. This means angle POR will be same as angle QOS, and angle ROQ will be same as SOP. So these are the two pairs of vertically opposite angles and they will be equal. Now there is one more condition right here. You guys remember, if there was a straight line, if there was a straight line and a ray was falling on that. Now you can look here. Let's just focus on our PQ. Let's say PQ is a straight line, right? This is a straight line and a ray OR is falling on it. Then there are two angles right here. Sum of those two angles will be what? It will be 180. So that then what happens here is angle ROP plus angle ROQ. That will be what? 180 due to linear pair, right? So as per linear pair, the sum is 180 and I know angle POR ratio, angle ROQ, that is what? That is 5, 7. So do what? Let ratio equals to x, or you can use sum of ratios also. That means you can just do it like this also, 5 over 12 and multiplied by 180, then 7 over 12 multiplied by 180. Then you can have these also. So let's just do what? Let's take ratio x. We will be having a 5x plus 7x, that should be 180. So 12x, that should be 180 and x should be what? It will be 50 degrees, right? So our first angle is what? It is 75 degrees. Considering POR has the ratio which is 5, so it is 75 and this will be 105. Now you guys know they are vertically opposite. So if this is 75, then this is 75. If this is 105, then that is 105. Or you could have done it like this also. Firstly, you would have assumed your vertically opposite angles. Yeah, you can prove that one also, beta. You can use that method and prove the remaining pair also equal. So see, you could have used your vertically opposite angle theorem also here. You could have done what? Taken this A and this one A because they were vertically opposite. This one B and that one B. Then you guys see, sum of all of these angles will be what? It will be 360. Then you would have done what? You would have done it like this. 5x considering this one, 5x considering that one, a 7x considering this one, and a 7x considering that one. Then you would have put it against 360 and you would have still got the value which should have been 15 degrees for that matter, but that does not matter here. So you guys see, you can do it like this. Now example 2, we have this one. So in figure 6.10, which is this one, OS stands on line POQ. OS stands on line POQ, which is this is the line and that is the ray. And the OR and OT are the angle bisectors of angle POS and SOQ. See, what happens here is, firstly let's draw this one. I have POS a line, sorry, POQ a line, and there is a ray PS, which is this one. What happens here is, since we are having rays and lines, so there will be two angles, right? One this one, one that one. And this is angle POS and that is angle SOQ. Now what happens is, I have two more rays, OR and OT. Both of them are bisecting the angles POS and angle SOQ. They are bisecting them. Then I have to find the value of angle ROT, which is this one, ROT, this full. Now you guys see, since OR and OT are bisectors, right? Since they are bisectors, then I can say angle POR should be same as angle ROS. Since we are talking about bisectors, bisectors do what? They just divide any quantity into two equal parts. Now you guys see, we are talking about this entire angle. So this will be divided into two equal parts, right? So this part right here will be same as that one, and they have already used this notation to show that both of them are equal. So you guys see, angle POR will be same as angle ROS. Also, since that is also happening on the other side, so angle SOT will be same as angle POQ, right? So in short, angle POR can be written like this. Angle POS, sorry, not POR, actually angle POS. Can I write it like this? Angle POR plus angle ROS, right? Adding this and that will be giving me this whole quantity. And I know both of them are equal. So can I write it like this? Angle ROS plus angle ROS. So angle POS is actually equal to twice of angle ROS. I hope you don't have any doubt in this, right? So this will be twice of angle ROS. Similarly, if I just write it here, similarly I know angle QOS, that will be equal to what? Angle SOT plus angle TOQ, right? So guys, see, SOT and TOQ are equal themselves, so angle QOS likewise will be equal to twice of angle SOT, right? The reason why I'm doing it like this, I will be explaining while we are on the last step. So remember, angle POS and angle QOS, I know sum of these two angles, angle POS, that means this one, and angle SOT, that means this one, these two will be acting as linear pair, and their sum will be what? Be 180. And since their sum is 180, I know this angle POS is twice of this one, and this angle SOQ will be twice of SOT. So guys, see, if I add these two, if I take 2 common and sum of both of these two angles will be angle ROT, that will be same as 180. So ROT will be what? Half of 180, and that should be 90. So this is my approach to this question. So remember, we have these two things now. So in short, if POQ is a line and OS, not angle, and OS is a ray falling on it, then angle POS plus angle SOQ will be equal to 180. That will be linear pair. And I already know that POS is same as twice of angle ROS, and SOQ is same as twice of angle SOT, which is equal to 180. So if I take 2 common, I will be having angle ROS plus angle SOT, that will be equal to 180. Now guys, see, ROS is this one, SOT is this one. So if I add these two, I will be having what? Angle ROT, which will be equal to 180. This 2 is in multiplication, on the other side it will be in division. So divided by 2, that will be 90 degrees. So this is the answer of this question. And with this, I'm gonna wrap it up here. We are going to be having our exercise 6.1 tomorrow, because almost we have taken 1 hour, and now we have to just do our exercise 6.1. So I will be having that tomorrow along with the further concept of this chapter. So join me tomorrow if you want to learn more with this. So do join me. And remember, if you have to recall each and everything and you have to practice till here whatever the concept that I've told you. So just go through this video again if you have to, make a proper notes of this chapter, then just come back tomorrow and we will be having more portion of this one. So I hope I will be seeing you tomorrow, and this will be it for now. I'll see you tomorrow now. Bye for now.